The Milky Way galaxy, home to 100 billion planets, home to our solar system, home to all known life. Where did it all come from? Until 1931, it was believed that the universe had always existed in its current state. That is, until Belgian priest and astronomer Georges Lemaitre proposed what is now known as the Big Bang Theory. The Big Bang Theory is the widely accepted explanation about how the universe was created. The theory says that all the matter and energy in the universe, all that we can see and all that we cannot see, was collapsed upon itself into a single point of infinite density, otherwise known as the singularity. The singularity began to expand under a process known as inflation. We would have to wait 400 million years until the first stars would form. Over the next 13 billion years, the universe would see the development of galaxies, planets, and other celestial bodies. Notice here the afterglow light pattern that was created only 400,000 years after the Big Bang. Its existence was confirmed by NASA's WMAP probe, also displayed in the diagram. Here's a closer look at the results of the WMAP probe. Think of this as a baby picture of the universe. In reality, the image represents minute temperature differences within an otherwise evenly dispersed microwave light that blankets the universe. The WMAP probe is named in honor of the cosmologist David Wilkinson of Princeton University, who was a member of the WMAP team. This is just one example of how humans have harnessed the power of technology to further understand the origins of the universe.
Hi, I'm Erin, and we're in the tunnel that houses RHIC at Brookhaven National Laboratory. The Relativistic Heavy Ion Collider, also known as RHIC, is a 2.5-mile particle accelerator and collider built with powerful superconducting magnets that accelerates two separate beams of particles at nearly the speed of light. One rotates counterclockwise and the other clockwise until they are steered into one another. A massive detector, like this one called STAR, captures the resulting subatomic particle collisions. Like a sophisticated digital camera, it provides us with insight to the behavior of matter at the dawn of time. 13 billion years ago, there were no protons and neutrons. Instead, there was a sea of free quarks and gluons. Quarks and gluons are the building blocks of larger particles like protons and neutrons. RHIC is able to create this pre-mortal state of matter called the quark-gluon plasma, which simulates the conditions just after the universe was created. Today, RHIC is exploring the transformation from this gluon plasma into the ordinary matter that we see today. This is a capability unique to RHIC.
Like RHIC and the WMAP probe, the Hubble telescope also contributes crucial data to the scientific community regarding the creation of the universe. The Hubble telescope provides astronomers with clear views of the universe in infrared, visible, and ultraviolet light. By looking deeper into space with its extraordinary capabilities, it allows scientists to peer deep into space, and therefore back in time. This has allowed scientists to measure the size of the universe and the rate at which it is expanding, which is then used to extrapolate the age of the universe, which we now know is approximately 13.8 billion years old. Before Hubble, scientists and astronomers were only able to narrow down the age of the universe to about 10 to 20 billion years old. We have learned more about our place in the universe in the last 100 years than we have in all the time before that. And what is now obvious is that there is an extraordinary amount of unity between the very large and the very small, and the very old and the very new. An underground particle accelerator is trying to answer the same questions as a telescope 300 miles above the Earth. It is an inspiring fact to know that the answers to the questions regarding our origins can be found in so many different places. The answers are all around us. We just need to keep looking and never stop asking why.